Imagine Communications. And Tony Pearson here. I'll let him get on the mic for a moment and introduce himself.
Good afternoon. I'm Tony Pearson, Associate Director for Media Production Services at North Carolina State University. And just to give you a little bit about North Carolina State University, I'm here to represent our distance education program. The distance education program produces courses for students that normally don't come to our traditional campus and stuff. And you can see the stats up here from last year. Basically, we do a lot. Basically, I have a production team that relies on a network operations center to monitor distance education courses. We monitor live classrooms, synchronous learning, asynchronous learning. A lot goes on in those classrooms as the stats produce here. And then of course what we're here to talk to you about is 2110 and how we've implemented a 2110 standard across our campus. We're showing you our campus locations right here that indicate every place that we've ran fiber. And the fiber is the key to our 2110 implementation here. And this is our main campus routes, and you see two lines running off the map there that go to our Centennial campus route. And that was somewhat of our question, as could we support those two campuses out there on the island on our other campus over there. As you can see, the distances right there probably causes a little bit of an issue when we talk about the distance as to where those fiber runs was going to go and how we can get that data back and forth between the two campuses. Of course, that's where Cassidy comes in to our solutions provider here to help us out with this equation and to work with us on the implementation of this. So I'm going to let Cassidy come back up.
So what they had was 4 strands of single mode fiber to each classroom location. So you can see they have 36 strands here. Black lines are the single mode fiber. So they could do one uncompressed SDI signal over each of those strands. So they were using a combination of equipment to get audio and video back over those strands. What we're doing now is using 2 strands of single mode fiber for 32 by 32 HD, 16 channels of audio per HD video. And then we have 2 strands available for future expansion. So fiber optimization was a big motivator here, and I'll let Tony talk a little more about that after I get through some of the initial diagrams, but talk about what we're actually doing with the workflow. So we have our SDNO, our broadcast control system for the multicast routing. So the entire distributed campus acts as one giant router. And then we have a Crestron system that sends basic GPI. I'm actually going to stop down here for just a moment. There we go. So talk a little bit about that workflow, Tony, what the actual workflow during a class session is and how the teachers interact with you guys and what you do back in the control room.
Okay, so to speak a little bit more about our workflow pretty much consists of a course going into a classroom, faculty, students, that could be anywhere from a 30-seat classroom all the way up to a 90-seat classroom. And typically we're recording classroom captures. Well, we're going to record the content of that course, the computer slides, the audio. Each classroom has 6 cameras inside the classrooms. So it's pretty much a production going on here. We take all those sources back into our system and transmit them over the network back to a centralized NOC. Everything's done remotely. So we have technicians that are located at the NOC. They're monitoring multiple classes at the same time. So they may not be dedicated to one particular class, but the system allows them the flexibility to allow the instructor in the classroom to push a help button that says, hey, I need some help. So push that help button and some triggers go off and they fly all the way back to the NOC, and we have salvos set up to where it just triggers things on the multiviewer that basically says, okay, engineering building 2 has a problem. Okay, so I've got 7 technicians sitting in there, and any one of those technicians at any time can say, I got it. And so they can say, well, that's my class, I'll take it. So they push a button and they can transmit the likeness of themselves and their audio back to the classroom. Hi, Dr. So-and-so, how can I help you? Dr. So-and-so say, hey, the camera's not moving or the projector's not working. Technicians can, once again, they can look at the back of the room, they can see the technician there. So there's a confidence between the instructor and the technician. That was one of the things that as we did it over time, we had to realize we had to give them a level of confidence that they could rely on a human body versus just talking over a telephone. And so basically the technician can take care of anything at any time, turn everything back on, reset the camera, Dr. So-and-so, you're good to go, continue recording. And that's kind of how our workflow is established. And so it's real-time interactivity between the classroom and the operating technicians remotely located. Yes, sir. Okay, so his question is how many technicians we have on staff. There's actually 7 full-time technicians that monitor, but then there's a a technician lead as well. So there's about 8 technicians total. We have a lead there, and then there's an operations manager as well. Okay, those are the full-time technicians. Being that we're a campus and we're students, we actually have part-time technicians too, but the part-time technicians serve mostly as runners. So if there's a severe issue in the classroom that can't be taken care of remotely, we deploy a runner out to the classroom. So they're on call somewhere within our building paths there, and they can be deployed to a classroom if needed. The other beauty of that is that's tier 1 level. We also have tier 2. So our tier 2 is a higher level technician that can go in remotely and take care of a situation that maybe the tier 1 can't take care of. And that's our engineering team that will step in from there. And then tier 3 is our higher level engineers that if something breaks and it needs to be repaired, they can go in with the redundant equipment and take it out and swap it out and get it going. Okay, so his question is, are the tier 2 and tier 3 guys full-time employees? Yes, they are. Tier 2 and tier 3 are full-time employees and stuff. The 8 tier 1 employees are full-time employees as well and stuff. We have about 5 part-time employees that act as tier 1, what we call runners. Okay? All right.
So, and we'll talk about this throughout in the other diagrams, but one of the things you'll notice here is we have a Cisco Nexus switch as the core. So this is a COTS core system, which is one of the advantages of the 2110 standard, is multi-vendor interop and being able to utilize a COTS system, or consumer off the shelf, which is sort of an overstatement because they're a very special switch. You have to meet certain qualifications of an enterprise data center to be able to run 2110 through your system, but this model does it. They also use a Tektronix SPG 8000A for precision timing protocol. That is the synchronization of the whole system. So AES 67 audio, 2110 video. The AES 67 audio, of course, is SMPTE 2110-30 interoperable. So this is all PTP IP. And then we use the Selenium Network Processor Gateway for IP to IP processing and gateway of SDI devices. And we'll talk more about the SDI devices in the system here in a little bit. So the question is, are we using the SNP for frame sync? And the answer is yes. And I'll talk about that here when we get up here. Stop down right on this slide. So this is more of a sort of a logical map. So we had those high level maps of the campus. This is a logical map with the equipment. And you can see I have the classrooms broken out. And we have 8 classrooms, actually 8 SNPs. One serves 2 classrooms. And there's still SDI cameras. Now to the frame sync question, back it up. Always that. So to the frame sync question, not all of these cameras are 720p or 1080i or 1080p. So we do have to use the frame sync capabilities of the SNP in a couple cases to do up-down cross conversion to make the router one format. We don't have to worry about pulling. Are you pulling reference to the SDI cameras, Tony? We don't even worry about that. They free run, and then we plug into the SNPs, and then they become synchronized to the house PTP. So that aspect of the frame sync we don't have to worry about. And then the audio is actually recorded separate from the cameras, so we can adjust the synchronization between the two. Of course, in 2110, it's fully demuxed, so to speak, so you have completely separate essences, and we could adjust those audio channels separately anyway. So again, just high level, we have the control servers at the top of the map there, and then we have control panels. They actually remote access the panels. They don't use the physical panels as often as the remote web interface of the router panels. And they do a lot of trigger presetting of layout changes in the multi-viewer rather than individual destination source take routing. Although they could, they do have the ability to have this act as one 256 by 256 squared routing system despite the distribution. The Tektronix SPG 8000A is in there in a redundant configuration, so they do have dual PTP generators if something were to happen, or if there was a drift on the primary, the backup would take over. And then we have the Epic Multiviewer, which is actually a COTS-based multiviewer. We'll talk a little bit more about that in a moment. They have another Selenium Network processor in the core to just do general processing functions that might come up in the engineering core. And they have a Tektronix Prism for waveform vector monitoring. So the Prism has traditional vector scope presentation, but also has IP analysis for 2110. So, Tony, tell us about your timeline and why you did this.
All right, you may have to stop this thing. All right, so basically this was not a quick process. We started this process back in 2015. We started engaging, the research side of things. We wanted to see what was next gen technology to replace some of our aging equipment. Some of the legacy stuff that we had in place was old SDI multi-viewer systems, and the way we did it in the past, we did a multi-viewer feed to feed a multi-viewer feed, and we used those 4 fiber strands at that time to send multi-viewer feeds over to the NOC. So it really limited what we can do. We were kind of handicapped because we could not unravel those signals. They were all multi-viewer feeds that were coming in, and all you saw was the quads. And so it didn't give us a lot of flexibility to pull out signals and directly work with those cameras and things like that. So it was a little bit of a handicap. In 2016, we started to engage vendors, and we started to go through an evaluation process and stuff. And so we looked at tons of products and solutions. We talked with about 7 different manufacturers, probably evaluated about 20 to 25 products over that time and stuff. And then we looked at everything from multicast, compressed video, uncompressed video, what was going to be best. We engaged our network engineers on campus to see what would you allow on the network. We already had the fiber infrastructure in place, and we knew that was always going to be a backup for us. So it was then when we got around to October 2018, it was decided that, hey, we need to look at 2110. We have been following it over time and seeing where it was evolving, and we asked Imagine to come in and do a 2110 demonstration with us and everything and stuff. And that was after we'd done all the other evaluations. We brought them in, saw their demonstration, looked at it, talked about workflow. How does it fit the workflow? Does it allow us to scale when we look at future-proofing our systems and things like that? So that was at that time where we decided from a collaborative standpoint, after collaborating with Imagine, collaborating with our integrator, collaborating with our engineers on campus, our network engineers, the fiber architects, and everybody like that, it was determined, hey, let's go ahead and see if we can do something with this product. And it was at that time that we decided to go ahead and request the designs for a 2110 system to come into play. And that was back in 2019 when we rolled that out. And then April 2019, we decided to go ahead and leverage and move forward to replace the legacy SDI system and finalize that and stuff. And then May 2019, we sent out a purchase order and start the process going, all the wiring and everything begun. August 21st to be exact, 2019, live production started from our NOC and stuff. So up until this point, right now today, we've been doing live classes with this system. Okay?
So, why was 2110 interesting?
So, very good question. Why was 2110 interesting? Flexibility. It basically just allowed us to expand what we were doing, unravel those multi-viewer feeds that we had already. So basically all the signals that Cassidy talked about earlier in the diagram they showed, we had the capability of bringing all of our signals back into play and stuff. Each classroom has about 15 to 16 sources inside of a classroom. Now we could independently bring those sources over and talk about how do we use this system for future-proofing in the future. It opened up a whole world of opportunities for us and stuff. So basically it allowed us to run what we thought wasn't going to happen. There were some concerns that we wouldn't be able to make the 10 kilometers. There might be some issues with that and stuff. So we talked about it, went back and forth, collaborated with it. We decided to take a chance and stuff. Actually, our chance worked out because the farthest site that you saw on that map was the first site that came live and stuff. And there was no tweaks, nothing had to be done with it. Pretty much was plug and play. It was that easy at that point in time. We didn't know that going into it, but that was a blessing for us that it worked and stuff. That opened up our integration across campus. That showed us now, not only could we integrate the rooms that we already had in the 9 buildings, we could start to think about future buildings as well and how to integrate those capture systems in those buildings as well and stuff. So basically that's kind of where we were. We were looking at 2110, the design, the future proofing, and then basically using the COTS technology to make that happen. Okay?
So I'll add a little bit to the COTS advantage. So FPGA-based and server-based technology allows us to make software upgrades in the field, firmware updates in the field. So already, as new features have become available, we know that Tony's team is planning to add certain things over time, or maybe change how they use some of the physical equipment, what it's actually doing in the system. So whether that's adding a different personality to those Selenium network processors or just doing some sort of a software update to their multi-viewers to get other features, they have that capability with COTS technology. So benefits of 2110 for this system: physical scale, using 10 gig, 25 gig, 40 gig, 100 gig fiber infrastructure. So again, this allowed us to use 2 strands of fiber where they used to have only a single HD video uncompressed of 1.5 gig. They're doing 1080i and 720p. Now they can do 32 3G signals on one strand of fiber going one way and 32 coming back the other way. So fiber optimization was huge. We can mix different types of connectors going back to the switch. So in this case, we use, in the engineering core, they have direct attached cables, active optical cables. So those are the short reach, pre-terminated cables. And then obviously they go to single mode transceivers for those long runs to the classrooms. We have, and we'll talk more about this when we get to the Cisco, but this uses less rack space and fewer cables than what they used to use. So in addition to the fiber optimization, the rack space is far less than you would need for an SDI version of the same system. Because they have those additional fibers waiting, they could make this a 2022-7 redundant model. So that's the dual transmit, dual receive model, where you'd have simultaneous send and receive, and then the receiving devices can cherry pick the best packets off of the A and the B networks. So potentially, if you're in a live operation, you're transmitting your class out to the world, and you have a hit, you're not going to see any effect to the outgoing path. You're just going to have an alarm saying that network A or B was dropping packets. So that's what the -7 model was about. Going IP means you never have to say you can't make it bigger. So we can scale vertically and horizontally. We can go to larger roster formats like UHD, or we can accommodate more signals and connections using the COT switches. So the benefits of the audio: SDI is limited to 16 channels of audio per video, requires embedding and de-embedding at every touch point. In ST2110, the audio is sent in separate IP streams. The audio console or audio system can subscribe to every stream it needs or generate new streams. Separate audio, total flexibility. So you have the video essences separate from the audio essences, and we can actually repack the audio channel per stream however we like, from 1 channel per multicast stream to 8 channels per multicast stream. And of course we have a control system that will allow you to route that multicast and have it behave like an SDI system and move the audio and the video and the ancillary data such as closed captioning or other metadata all under one control system that's essentially going to feel like destination source take regardless. So precision timing protocol uses the same physical cables and switches as the media. There's actually a precision timing protocol based timing stamp on every single packet. So when I'm looking for the video from 10 a.m. and the audio from 10 a.m., my receiving device is just going to align all those packets based on that timing stamp. The data comes in the same way. So this means you don't need to have a separate infrastructure for reference, black burst reference. You don't need to have a mix of different timing systems. It just reduces the infrastructure. PTP is format flexible across SD, HD, 3G HD, and UHD. And of course, timestamps on every packet. So this is a big one for Tony, and I'll let Tony take this one. The benefit of 2110 and being standards-based to allow choices and flexibility.
So the big benefit here is the multi-vendor aspect of it. That's allowing us to just use multi-vendors to make this system work and stuff. And so we're able to basically go into buildings, use different vendors. Uh-oh, I messed it up. Not familiar with this one.
No, me either. There you go. And then the arrow will get back and forth.
Where are we at here?
There you go.
All right. So it basically is going to allow us in the future to choose our cameras because we just did the core. Basically, we put in this infrastructure to drive the core. So that builds the foundation. It now allows us to go back and think about how we implement 2110 into our classrooms. And so it allows us to choose our cameras, choose our switchers, our relays, everything that needs to go into the classroom and stuff. And so being an educational institution, I don't know when that's going to be. So budgets are everything. But the beautiful thing here is I built the core. The core is built. Okay, so now I go back and our game plan is to look at how do we update classrooms on what used to be a 10-year plan, now more or less a 4 to 8 year plan, how to update our classrooms. This gives us the flexibility to take our time, to continue the evaluation of the products, continue to look at the cameras, the switches, and everything that need to go in the middle there, and make the classroom upgrades in an educated fashion. And so that basically allows us to have a level playing field. We can go out and talk to the vendors, we can go out and talk to the manufacturers, and already understand what our core is, and now let's see who can play within the core stuff. And that was our goal in coming up with a system like this, is can it be flexible, can it give us scalability into the future?
Talk a little bit about the Nexus, if you don't mind. So the Cisco Nexus switch that Tony's using can handle 7 terabytes per second. So we could support, if you're thinking in SDI terms, a 1,200 by 1,200 3G matrix. So that's one rack unit doing everything that you would need 2 28RU routers to do in SDI world. So AES67 can be introduced. He could add his camera links. He has additional ports open. If they need to go to a bigger switch, there are bigger switches. So the flexibility that this system allows, and they could have a spine leaf configuration where they put switches closer to the classrooms, aggregate 1 gig, 10 gig links up to 100 gig. Someday there could be 400 gig if they needed to go that way. So the flexibility of using this COTS-based system here is expansion and the options that Tony talked about. So just again, so you can see it, here's the server that the multiviewer lives on. You can see the input cards are literally PCIe cards into the server. So it's a familiar technology for the IT department in some ways. This is the gateway device. So this is actually living in the closets next to the classrooms. And we use the HDBNCs to bring that SDI in. And it's basically, in a very abstract sense, acting as sort of an aggregation device for SDI links. And then you can see the yellow to the left there next to the power cables. That's the 100 gig link with LC connectors. And we still have room to expand even on that unit. We have unused SDI ports. We have SFP ports that could be used for MADI back and forth. And I'm going to pause here and let Tony talk about the differences.
So some of the differences, as you see, the before pictures up there was the multi-viewer feeds that I spoke about earlier. Basically, cobbled together multi-viewer feeds that went into a different monitoring solution. You know, while we were at it, we went ahead and changed our monitoring scheme and went from 4 monitors to an actually 1 monitor solution. So the after pictures here show the new product there. At the very top of the screen there, you can see those gray boxes. Those are a tally indicators. So anytime someone pushes a help button, you'll get a red indicator that comes up that identifies that room that's having a problem. Not only do we get the red indicator on the screen, you see the sound tube speakers in there, we get a little audio-visual cue as well that says there's a problem here in this room. So any one of those technicians at any time can grab hold and take care of that solution. They also have the opportunity to see their talkback camera, which is on the monitor as well. So they send that particular camera feed of them from that console back into the classroom. So they can view every single source this time around and stuff. They don't have to reroute things. Before, we had to actually route things within the classroom to get them into the quad multi-viewer feed there so they can even see anything. Right now, we can see every single source at the NOC. So any of our synchronous codecs that we were using for synchronous courses, in the past they had to route those. Now they can see every single source. They can go full screen on any source at any time. They just go ahead and pull up that multi-viewer page that says go full screen on the source. So it's a completely flexible system. It's a very nice system. Workflow has increased our efficiency levels. They can respond a whole lot quicker. They don't have to do any internal routes anymore before they respond to anything and stuff. So that's kind of what we're dealing with right now. We're looking forward to moving forward into the future.
It's just a summary page. Go ahead if you want to. I'll take it. I'll take it. So to summarize here, just the right gateways extended the life of the functioning SDI devices for years to come, so they can upgrade those cameras or whatever when they feel like they need to. SMPTE 2110 provides a level playing field, fiber optimization like never before, flexibility to move everything. Another point that we should make is anything that's on that network is a resource on the network. So the processors that are 10 kilometers away, because we have that bidirectional link, we could do frame sync on something that came from another part of the campus in a processor that's 10 kilometers away. Part of that same flexibility of a COTS-based 2110 system. No more tie lines. This whole thing is one big router. So to Tony's point, the steps on the routing, he doesn't have to get on the phone and ask someone to do something somewhere else. they can do 1 click or 2 clicks from that central control room. So that's the presentation we have. You guys have any more questions for us? We're here. Bring it.
So the question is, how many classrooms we have it installed in? It's actually installed in 9 classrooms. 2 of them share an SMP. So, we have enough capacity on that one SMP to drive 2 classrooms. But basically 9 classrooms right now. Okay. Any other questions? And if you have any questions after, feel free to stop by, see one of us. We'll be, willing to talk to you directly. So, all right. Thank you.